Everyone. You're in AUTOMAGIC tuning in SQL Server, and if you're online, hi. If you have any questions, raise your hand. Just ask at any time. Don't worry about interrupting me. I'd rather you ask when we're in context. In this session, we're going to talk about a series of new features that have been added to SQL Server since really SQL Server 2017, but they kind of build on stuff that was built in the query store in SQL 2016. And we'll talk about how they work. We'll do a lot of demos, where they're implemented. And this is a little bit of a two-part session because my colleague John Morehouse is doing a session tomorrow that I'll link to at the end, where he's going to cover some more of the stuff that's introduced in SQL Server 2022. I will be demoing in 2022, but I'll make sure I mention which versions these features all come in. The other thing to note is all of these features are I think all the features I'm going to demo are available in all of the cloud versions of SQLDB. I'd like to thank our sponsor. Make sure you get to the sponsors and say hi. They help us have conferences like these, and it's awesome because we get to travel all over the world and talk to various folks and help you learn more about SQL Server and Azure. I'm Joey D'Antoni. I'm a data platform MVP. I'm principal consultant at Denny Cherry & Associates Consulting. I live in Philadelphia in the United States. You can find me on Twitter, Facebook, LinkedIn. I also write a monthly column for Redmond Mag called Joey on SQL Server. I recently wrote a column about this cool new feature Microsoft introduced called the Data API Builder that lets you build APIs on top of your SQL Server database in like 2 lines of code. It's really awesome. So this slide is a series of major features that have been kind of introduced, but I want to take a step back and kind of talk about the history of this. One of the things that's been really interesting about Microsoft becoming not just a software company, but a hosting provider, they've had to really refocus their development teams around doing operations management, which means, yes, people who write code actually are DBAs kind of now, which also means they see a lot of the problems we've been complaining to them about for the entirety of my almost 30-year IT career now. And they fix them faster, which is nice. So one of the things they built in SQL Server 2016, and this is what a lot of these features, specifically automatic tuning, build upon, are the query store. So who has heard of the query store? Raise your hand. Ooh, that's bad. Okay, that's like 30% of the room. Hey, Monica, call Aaron Stellato a stat. So the query store is this amazing feature. It's probably my favorite feature in SQL Server. It was introduced in SQL Server 2016. They like to call it a flight data recorder. It effectively captures what queries running at your systems, what their estimated execution plans are, and what the runtime statistics are against those queries. So this builds a really nice history of performance and change, and having that log allows you to build a lot of intelligence and features. So you can know when a query suddenly goes a lot slower and potentially take action. And that's what some of these features do. A couple of these other features that we're going to talk about, like memory grant feedback and multi-statement table valued function processing, they actually just change some of the ways the optimizer works and allow for changes. So the query processor, if you're not familiar, when you submit a query to SQL Server, it does a few things. The first thing it does is says, hey, do all these objects exist? Do the tables and columns, are they all exist? And does the user who's executing this query, does their context have security to access those things? That's the first part. That's pretty basic. We call that parsing. The output of parsing goes to the query processor and then generates a series of plans based on the statistics of the distribution of data and the columns and the indexes that we see fit. And one of the things that comes out of that is a memory grant. So if you're doing any kind of a join operation or a sort operation or numerous other operations, a certain amount of memory has to be granted because those operations take place in memory because they would be extremely slow on disk. However, let's say we were joining, 200 gigabyte tables, and for whatever reason, our stats said, oh, there's only 10 meg of data in each of those tables that we're going to join, and so your memory grant was 20 meg. What's going to happen? SQL Server needs someplace to fulfill that join operation. So it's going to spill out to disk tempdb. So if you're familiar with the concept of a page file in an operating system, where if you don't have enough memory, it spills out to the page file, tempdb does that for SQL Server. And we can have these spills for various reasons. The other aspect we can have is, if anybody's ever seen a wait type in SQL Server called resource semaphore, where like we had the other example where we had 20 meg of data that we were joining, but SQL Server thought we were going to have, 200 gig, and it allocated 200 gig. Well, no other queries could execute because they couldn't get a memory grant to run. So we greatly harm our concurrency when we see those resource semaphore waits. This is one of the features, memory grant feedback, that will adjust that on the fly, and we'll see a demo of this later in the talk. So when we're optimizing those queries, there's a step called cardinality estimation. And this process is responsible for estimating the number of rows that are processed at each step of the execution plan. One of the things I want you to take away from this session, it is very, very important to have up-to-date and good statistics on your data. That's what helps the optimizer work better. That's going to be what gets you the best estimation plan. And you may say, hey, SQL Server has, or we have auto update statistics on, and that's fine, especially if you're on a version of SQL Server newer than 2016. If you're on a version older than 2016 and you have very large tables, auto update statistics won't trigger until 20% of the rows have been modified, plus some number that I don't remember, like 10,000. If you have a 2 billion row table, that's a lot of 20% of 2 billion is a lot of rows. That's 20 million rows, I think, or 200 million. So that requires a great deal of data to change. So what you can do prior to 2016 is enable a trace flag. That trace flag number is 2371, and that will change the scale of how SQL Server makes estimations. That behavior is built into the database engine on all versions newer than 2016, or 2016 and newer. So the cardinality estimator makes a number of assumptions, and then it looks at the statistical techniques, and that's how it starts to build the process of building a plan. When those estimates are accurate enough, the engine's going to make informed decisions because it knows what the data is. It knows what the distribution of the data is. Sometimes, just to give you an example, my coworker John is in the room, and we once had the worst table I've ever seen. It was 2 terabytes, and about half of the table was distinct values. So 1, 2, 3, 4, or it was a key value store, and about half of the table had just a key and then a value of a string of HTML code. I don't know really what this table was supposed to be doing. These HTML codes were like up to a couple of meg in size. The other half of the table, why this data was all in one table, I will never know. It's a great mystery of life. Was like 1, true, 2, false. And those numbers had, like, there were 10,000 distinct values there, and they had a large number of repetitions. So like maybe the count of true was 10 million. So you had this really, really screwed up data distribution. And when you had that, the optimizer just kind of cries because it doesn't know what to do because it can't make good statistical assumptions. So the only reason why I point out that example is there are sometimes edge cases where you'll never be able to get an optimal plan because of weirdness. And there are some workarounds for that, but they're all hard. So some common reasons we have incorrect estimates. Missing indexes, or excuse me, missing statistics. Does anybody use Ola Hallengren's maintenance solution? Okay, good. About 10% of the room raised their hands for those of you in the crowd online. One thing to note about Ola's maintenance solution, if you install it with the defaults, it doesn't force update of statistics. Theoretically, with auto update stats, you don't need it, but for the cost of updating statistics, I really like to do it manually, just so I have better data. Like I'd rather have more data than less. Stale statistics. So if you maybe run into a database that doesn't have auto update statistics on, your data is changing, but not enough to trigger those stats updates. Old statistics can be just as much of a problem. Inadequate sample statistics rate. Monica, what's the default? I think it's like 10%. The default is 10%, which is typically enough. I think. I figured you might know off the top of your head. Sorry. Uh, let's just go with 10%. 10% is usually an adequate enough sample rate, but if you have weird data skew in your distribution, that can lead to misleading values. The common way to, like, my DBA way of doing quick statistics analysis is to do a select value, like whatever the column you're looking at for distribution, and then the count of that value and see how they're distributed amongst the table. The classic example where we did this was that horrible 2 terabyte table. That query took 8 hours to run on that 2 terabyte table, by the way. It was kind of ugly. So that's another one. Bad parameter sniffing scenarios. Parameter sniffing is when SQL Server creates an execution plan. When you pass in a parameter, it creates it based on the first value that the procedure is compiled with. So if you have a bad data skew scenario, which we're going to show an example of one in some of our demos, your plan may be optimal for the first parameter, but it may be bad for other ones. I'm not going to talk about a new feature called parameter sensitive plans that are in 2022. John's going to cover that tomorrow. That helps address that in a lot of ways. But if you're not on 2022, you don't have that yet. Out of model query constructs. So a couple of these things have gotten fixed. We're going to talk about maybe multi-statement table valued functions. Table variables are a newer thing in 2019. These were things where SQL Server used fixed cost estimation and would say, like, a table variable is going to have 100 rows. If your table variable has, 10 million rows, that estimate's going to be really poor and you're going to get a bad plan. And then to get deeper into cardinality estimation, the assumptions that the cardinality estimator makes are not aligned with the data being queried. And one of these is the independence of the data versus the correlation of values. And this is something that's also slightly addressed in 2022. There are some enhancements around cardinality estimation feedback. So it can also take some, in 2022, SQL Server can help address some of these. So it's taken a few versions to build in a lot of fixes for these, but for the most part, the database engine is smarter about all of them. So the cost of incorrect estimates: slow query response time due to inefficient plans, excessive resource utilization, CPU, memory, or I/O, spills to disk when we don't have enough memory granted. Will spill tempDB out to disk, and disk is slow. Even if you have really fast disk, it's orders of magnitude slower than memory. Reduced throughput and concurrency. So if you're giving way too big of memory grants, you're going to see some ugliness. And then T-SQL refactoring and to work around off-model statements. Did anybody ever have problems with the cardinality estimator in 2014 when Microsoft switched it? A couple of people raised their hand. This was a kind of a major problem for a lot of. It was mainly bad queries. There wasn't like a consistent pattern of what went slower. But when Microsoft made some significant changes in SQL 2014 to the way cardinality estimation was done, and when that happened, it caused like 98% of queries to run a few percent more efficiently, and it caused about 2% of queries to run terribly. So that's something that's actually something that is finally fixed in 2022 mostly. This slide, which is a little bit of an eye chart in this room, I'll walk through it. This talks about the features that are introduced in each version of SQL Server in terms of intelligent query processing. The big one is the fact that's not on here is the fact that we got the query store in 2016. If you're running SQL Server 2016 or higher, or you're running Azure SQL, anything, you want to enable the query store in your database. We'll show it off in a couple of demos, not explicitly, but it gives you really good information about the performance of what's going on your server. But we got a lot of stuff in SQL 2017. This whole family of features called adaptive query processing, which is mostly what we're going to cover today, was added. So we got adaptive joins, interleaved execution, and query processing feedback. These were all the building blocks for some additional features. So adaptive joins kind of help decide after compilation whether or not the optimizer is going to use a hash join, which is more efficient for a large number of rows, or a nested loop join, which is more efficient for a smaller number of rows. We also got, as part of that, memory grant feedback, which works in batch mode, and now in 2019 it also works in row mode. And interleave execution allowed us to get better performance with multi-statement table valued functions. Instead of using a fixed cost estimate, we use the actual estimate of the plan. And then in 2019, we got some of these other features, or 2022 rather, like feedback persistence, max degree of parallelism feedback. If anyone's ever struggled with how to set max top, it can run at the query. And the other big three that I think are really useful: scalar user-defined function inlining. This makes scalar user-defined functions suck a lot less. Like, it was always a big anti-pattern in SQL to use scalar-defined functions. It's not perfect. That feature still has a lot of limitations in terms of the number of types of functions that it works with and code patterns. But if it fixes your function, it really helps a lot. And then the big one, I think, is parameter-sensitive plan optimization. And also in 2022, we get query hints in the query store. So you can force query hints on a query without putting them in your code, which is really nice. All right, let's kind of dive into each of the features we're going to talk about. So interleaved execution for multi-statement table valued functions. So before SQL Server 2017, we used a fixed estimate of 100 rows, and it could have major performance issues if you had orders of magnitude more data than 100 rows. In 2017 and going forward, and by the way, this is the one feature in 2017 that is in standard edition, I think. Somebody correct me if I'm wrong on that. So prior to 2016 or 2017, we thought they were a black box. Now with interleaved execution, the database engine is going to materialize the function, get the actual row count from the function, and then use that. So if there are 500,000 rows in the functions, you'll get much better performance. So there's very little overhead to doing this because SQL Server is already going to materialize the multi-statement table valued function. One thing to note, the first execution cached will be used by consecutive executions. So if it's kind of an outlier that you had 500,000 rows, you may be over-granting memory. And this feature doesn't have a feedback mechanism kicked in that I'm aware of yet. So it will reuse the plan on subsequent executions. It is mentioned in the plan that it contains interleaved execution candidates, and we'll mention that it's interleaved. And then you can also see this in X events, and that's something that's going to be common across all of these features. You can monitor for their usage using extended events. So let's do a quick demo. So just to show you real quick, I'll zoom in a bit, but this is SQL Server 2022. I just built this VM this morning. So we're going to use the Wide World Importers data warehouse database. And the key thing to note here is all these features are gated by compatibility level. So we're gonna show this first in compatibility level 130. And I'm going to set statistics, time, and I/O on. And here's our query, which is calling this this multi-statement table value function. What if outlier quantity? I can show you the function. It's a little ugly. So here we see it has a number of parameters, and it's designed to handle certain conditions, their if statements. It's a lot. So if we go ahead and execute this, It would help if I got in the right database. We can see that after a couple of seconds, we start returning rows. It took about 4 seconds to return. If we look here, we can see we had a work table. And if I dive into the execution plan, I can see I have these warnings, and I can see that I spilled to TempDB wrote 772 pages to TempDB, so I had a spill because of the incorrect estimate. So if I look back here, I see my estimated number of rows is 100, but my actual number of rows was 231,412. So not a good estimate. And like if we look in the stats IO, we can see this work table. This was our spill, and our total execution time took 4,028 milliseconds. So here we're going to set compatibility level to 140, which is SQL Server 2017. And now we're going to run the same thing. And now we can see it ran in 1 second. And so if I look at my stats, I still have that work table, but we see it took 1.2 seconds. Also, we don't have any spills. And if I now zoom into my plan and I look at my estimate, I can see now that my estimated number of rows and my actual number of rows match each other. So what this effectively was an out-of-model construct. I was trying. Oh, wrong database. Sorry about that. I was going to show you in the query store how we can look at this, but I need to get into the right database. So here, this is kind of the power of the query store. So one of the things I don't like about this, and we've been asking Microsoft to change, is it defaults to using total duration as opposed to average, because I'd like to know which query took the longest to run. But that's not really related to this query. But here I can see it was executed twice, and I have 2 execution plans, and one of them is much better than the other one. I can click on these and it'll show me these, but the other really cool thing here is if I shift click, which is what I just did, so you'll see both of those are highlighted. And I never remember what button is compare. There we go. Here I can see the plan comparison. So I can see both plans in the same window. Give me a second. I'll zoom in here. So here I can see the same operator, which is that table scan, and I can see my estimates. SQL Server is nice enough to pop up, or Management Studio is nice enough to pop up this big does not equal icon to draw your eyes to where the difference is. And here I can see that the estimate for the bad plan is 100, and the estimate for the good plan is 200,031. Any questions on that? Yeah, Erland?
Well, just okay, I don't know if you're going to mention it, but it's worth noting out. This is only for select statements. If you do insert, you have enough to do delete or even select into, it's going to be an estimated one.
Got it.
You still have to come around to fix it.
So one of the other features that we talked about and that common problem is the memory grants. This one is really kind of interesting. So here we're talking about batch mode. The slides from 2017, but this also works in row mode in 2019. And I have kind of a really good story where I got to tell Connor Cunningham, who's the chief architect of SQL Server, that he was wrong, which was the first time that ever happened, and it was kind of fun. I had a client, I live in Philadelphia, which is on the east coast of the US, and I was teaching a training class in Vancouver, Canada, which is on the west coast, so 3 hours time difference. And I was up very early because I had a client call at like 6 a.m. West Coast time. And while I'm on the client call, another client emails me like freaking out, like, our database is now running at 80% CPU. It runs at 20% all the time. This particular client, all they pretty much ever do is run the same query over and over again. They're collecting data. It's a kind of an IoT system, and they occasionally report on it, but they mostly insert. And I get on the server, and I'm like, I do my standard checks because they're like, it always runs at 20%. I'm looking for, ransomware or virus or something, anything random that can cause CPU. Didn't find anything obvious external, so I fire up SQL Server or Management Studio. It was early, so my brain wasn't 100% there. But about like 10 minutes of looking into their system, and I was like, oh yeah, I upgraded them to 2016, and I enabled Query Store. So I go into the Query Store and I look, and suddenly there was a kind of like we just saw in that last example, where there's an execution plan change. And suddenly the plan was a lot slower. So I'm like, hold on, there's something I can try. And so what I did, because it was kind of an emergency, you have the ability, the Query Store gives you the ability to force up a different plan. And we're going to talk about that with automatic tuning. But so I just forced the last plan and like, let's see what happens. And as soon as I did that, it was like, I wish I had video of this, because the CPU on the server just went like suddenly from 80% back to 20%. And so it turned out that I downloaded the plans and everything looked good. Like the plans all looked the same. I couldn't see any differences. And I was talking to Connor about it, and I was thanking him for building the Query Store and how amazing this was that I could fix this problem this easily. And he's like, I don't understand the problem. Those are the same plans. Well, it turned out that he was wrong. There was a memory grant change, and it wasn't too significant. But I'm guessing it just kind of crossed the threshold with how their data operated. And suddenly, because of that memory grant change, their plans started consuming way more CPU. And there wasn't even a spill to TempDB or anything. It was a pretty minor change. But it just goes to show you the importance of memory grants. So we have a couple of problems. We can either have too much or too little memory. Oh, sorry about that. So queries can spill to disk or take too much memory based on cardinality estimates. Memory grant feedback will adjust those based on execution feedback. It will remove spills and improve concurrency for repeating queries. This is something that's not consistently not persisted until 2022. Persistence is added in SQL 2022. So one of the things that Microsoft does here, if there's a lot of oscillation, and what do we mean by oscillation? Switching back and forth, which is going to be kind of the demo we're going to show you, where if you have one plan that gets way too big of an estimate and you have another plan that gets way too small of an estimate, it will get turned off after a while. And the example we're going to use is kind of a parameter sniffing one. So that is something that will kind of be addressed in 2022 by parameter sensitive plan feedback, but we'll see how the feature works. This also goes to X events, and it will show updates by feedback. And if we have a spill to TempDB, the size will be however big the spill was, that will be the increase in the next grant on the next execution. And for overage, it will reduce based on waste and also add a buffer. And this is all based on the plan that's in cache. So if the plan gets evicted from cache or you recompile, the memory grant size will go back to what it originally was. So let's kind of dive in and do a demo of this. So here we're going to go back to using our data warehouse. And we'll go ahead and create this procedure, and I'm going to fix this, because if you don't know, we used to have to do this annoying syntax in SQL Server, drop procedure if exist, but now, starting with SQL Server 2016 SP1, we can do this syntax where we create or alter a procedure. And here I'm going to make sure I have an actual execution plan. And so what we're going to do is use a key that doesn't have any rows. So we're passing in parameter of 8 here. 8 is not going to have any rows, so this is going to run very quickly, and it's going to get a very small memory grant. So here we see actually, based on the stats, it got what's known as an excessive grant. And so here we can, if I can hold my mouse steady, we see the query grant detected excessive grants which may impact the reliability. The initial grant was 67 meg, give or take, and it only used 856K. So if we run this again, we now see, we don't see that warning. And we can see the memory grant was only 2200K, so it's much smaller, so much more efficient. If we run it again, it may drop down a little bit more. I don't think it will, because that probably wasn't considered excessive. Yeah, it used the same memory grant the second time. So now we'll run with data. So now that this plan currently, as it exists in the store, has a 2200 kilobyte memory grant. If we're gonna run this and get a lot more rows, it's gonna spill to tempdb. So we're gonna see how this reacts. As we can see, this is much slower. We finally get rows back at like 12 seconds, and it took 15 seconds total. And if we look, we see it was 15 seconds. I don't see a particular table that was awful, which means the spill's not captured here. Here we can see this wrote 2,700. We had a spill, so we wrote 2,800 pages to memory, or to tempdb, because we only had roughly 2 meg of memory, and we needed more. We also see the sort itself, because we returned a large number of rows. That sort also wrote 3,400 pages to tempdb. And then we can see the warning, and we see grant increase. So if we go ahead and run this again, it's still not super fast because it's returning 231,000 rows. Most of the time on this is probably going to be returning those rows to Management Studio. We still probably have a little bit of a spill, because, let's see. We see the grant was bigger this time. So we had an 8,500 kilobyte grant. We spilled fewer pages, but we still spilled. So if we run this again, feedback should kick in again, and we finally should get a good plan, hopefully. Yeah, that seemed to go a lot faster. We're still spilling. We keep increasing the grant, though, so it doubled our grant this time. So we see the grant was 15,000 kilobytes now. The grant's now 22,000, still spilling. Let's see if we can get one more if it changes. Still spilling at 29. This isn't a super aggressive feedback loop, which is one of the reasons why we have to run it a few times. Now 36. $42,000. So we keep increasing the grant. We still keep getting a spill. $49,000. See if we can finally not get a spill. Hopefully. Yes, on the finally on the hash match, and then the sword's still spilling, so we'll run this one more time. We're up to 62,000. By the way, just T-SQL tip: don't like try to sort 200,000 rows all the time. Not really a good pattern. The sword's still not working in 68,000. We'll give this one more try. Finally, let's see what our grant was. 77 meg is what it took. That sorts a lot of data, so that's a really inefficient pattern. But sometimes in demos we have to show inefficient patterns because they make the demos work a little bit better. And you can see how memory grant feedback kind of steps through in order to increase that memory. It doesn't just do it all at once because that would be that could lead to negative connotations. Any questions about that? It will have, yeah, it'll have way too big of a grant. So you'll see we have that little warning there, and we can see the grant here is 84. 80. Oh, you can't see that. PowerPoint's a little bit annoying sometimes. So here we can see the grant's 84 meg, which this is the other extreme. So this would give you a concurrency problem. And by the way, the question from the audience was what happens if we run the query over again with no rows. And so here we see it will oscillate this slowly back down. So it's almost the inverse. So here if we do go 10, by my 10th query, it's down to 77. But yeah, it will work the same way to step it back down. This is where persisting it. So there, in the scenario that I showed you, there's like kind of two features that are important that are in 2022. Persisting that feedback associated with the plan, and that's done using the query store. So the feedback is stored. The term we kind of came up with was the execution context of the plan. So that feedback is stored with that execution context, but that's before 2022. That's only in memory construct. So as soon as the plan goes away from memory, you lose all that information. The other thing that would help this particular scenario is parameter sensitive plans. So in 2022, if I had PSP enabled, we would just have two execution plans, one that had a big grant and then one that had a smaller grant. So this is another feature. I also have a client story to talk about. Batch mode adaptive joins. This, like, of all these features, I think this is the one that people kind of notice the least. It doesn't really, it helps. It is very helpful. I have a particular customer that has like a very large data warehouse, but sometimes they do subsets of data. So having these joins be adaptive is really handy. But I had a customer, a very large customer who I can't name, where they had hash joins, or loop joins rather, hard-coded, like loop join hints hard-coded into all their major queries. Loop joins, if you're not familiar, it's a nested loop. So just like if you were doing a cursor or something like that, it's kind of a row-by-row operation that takes place in memory. They're really efficient because they don't have a lot of overhead. if you're dealing with a very small subset of rows, so if you're like comparing 10 rows to each other, or 10 values to each other, a nested loop's a really good way to do it. If you're trying, just like in SQL, right? Like if you're writing a cursor and you know you're only going to have 10 values, yeah, whatever, it'll work. If you're trying to compare a million values, you want to write those into a table and compare the two tables in one set beta based operation. That's effectively what a hash join is. In a hash join, you have the overhead of setting up that table and populating it. So for small amounts of rows, nested loop joins are more efficient. However, if you hint all your queries to use nested loop joins, and you have like 75,000 or 2 million rows that you're comparing, your query is going to eat a lot more CPU than if you did a hash join. What batch mode adaptive joins does is defers the choice of whether or not to do a hash or nested loop join until after the first join input has been scanned. And this uses a nested loop for small inputs and hash joins for larger inputs. And we have this lovely chart that I'll show in the next slide that shows where it kicks over. So one of the things about adaptive join is it does have a little more overhead, because SQL Server is always going to grant the memory needed for a nested loop join, which can be a little bit of overhead. This is in the plan attributes. We can see it. It's also in X events if it was skipped. And a single compiled plan can accommodate low and high number of row scenarios. So unlike the deferred join or the memory grant feedback, this is somewhat persisted with the plan. And we have this threshold, and you kind of can't see the numbers here, but it's 1 in 50,000. This is what Microsoft gave us. It's not really, they don't really give us a great deal of help on the x-axis. It's probably somewhere around 10,000 rows where it will switch over. And then let's just do a quick demo of this. So here we're going to go ahead and run this query, which is going to join our very common data warehouse query. We're going to join order to stock item. We can see that the query did go pretty fast. So that was a sub-second query. And then we're going to delete a row. And now we're going to insert another row. In here we can see our adaptive join. This isn't the coolest demo of the bunch. It's probably my least favorite. As I mentioned, this feature is cool, but you don't really see it. It just kind of works. But we can see that the join is adaptive. The estimated join type was a hash match. Did I not run a actual? I did not run an actual. Let's run that query again with an actual plan. Just in case everybody doesn't know the difference between an actual execution plan and a estimated plan, it's typically exactly the same plan. The difference is you get actual statistics and estimates, so you can compare the estimated and actual. In theory, the plan shape should never change. It is rarely possible that something weird could happen, and it could, but almost always your plan is going to be the same as an estimate and actual, because it's getting optimized by the optimizer with the same considerations. But here we can see the actual and the estimated. So our estimated join type for this query was a hash match based on the number of rows, but the actual type was a nested loops join because we had a pretty small input. I was looking for the number of rows was 5, so it made a lot of sense for it to do a nested loop. Like I said, of these features, this is probably the one you'll notice the least, but it can actually help a lot if you have kind of weird data distribution. So automatically fixing queries. I told you a story earlier about a customer where I got called at 6 a.m. and I've gotten paged at like 2 a.m. before on back when I had a pager. Uh, Various kind of scenarios just like that, where something caused the query plan to change. The amount of data changed, or like the amount of data changed, so the plan that was in use was no longer valid or no longer effective. Uh, and you get called. You have to log in. You have to retrieve the plan. It was ugly before the query store. We had a really hard time. What automatic tuning does is take what I did on that 2016 server and automate the process of it. So if you have to have query store, and if there's a performance regression, because remember the query store is capturing that data, and SQL Server thinks sees that there was a plan change, it can automatically resolve it, and it will try to use the last known good plan. So let's just take a look at this. We have like 14 minutes left, which is just enough time for this. So this is a really fun demo. So we're going to start this workload. We have a stored procedure called DBO report. It's just running a report based on package type ID. And we're going to run this 50 times so we can kind of see what the workload looks like. Let me set stats on so we can see timings. So the key thing, I'm going to set timing on so we have proof, but you're going to just visually be able to see about how quickly this executes. Based on just my results that's coming in. So here we're going to run this 50 times. I'll turn on the plan so we can see it. So you can see it's running and very quickly. And we finished in 12 seconds. So pretty happy. Whichever VM I'm using is better than whatever I used last time, because this usually takes 14 seconds. The execution plan is actually not perfect. It's doing a clustered index scan. If I remember correctly, we could tune this with an index, but then it would run way too fast. So here we're gonna run a procedure called regression. What my regression procedure is going to do: clear the plan cache and then run it with a parameter that's less good. So we'll just go ahead and run this. And just to show you that oh, I'm in the wrong database. That's why I can't see that. So it just does a DBC free proc cache and then runs the report with a parameter value of 1. Fun story, I once got a DBA fired because he had a client, because they were having performance problems every morning when the users logged in. And it turned out the DBA had a job where he dropped the plan cache and dropped clean buffers at right before the users logged in. And yeah, that was not good. Don't do that in prod. It's cool for demos. Okay, so we're going to run this 30 times. And you're going to kind of notice the difference in performance. Once again, like I said, we can look at the stats, but just watch. You can see it's taken a couple of seconds longer. And remember last time it took 12 seconds to run 50 times. In here, we're running at 30, and we're going to be at like 18 seconds. Yeah, 18 seconds. I didn't rehearse that, I promise. And here we can see we could improve this by adding, like, it's doing a key lookup, so it's not an efficient plan. We could fix that, but then this demo wouldn't be any fun. So if we go and look in Query Store, we see we have this one query and we have these two plans, one of which is really effective and one of which sucks. And we can also see in a catalog view or a DMV called system DB tuning recommendations that our average CPU time for the query changed from 118 milliseconds to 461 milliseconds. And we didn't change this because, as you can see here, automatic tuning option not enabled. So that means I didn't have auto tuning on. So we're going to drop everything. We're going to clear the query store again. And we're going to do this alter database set force last good plan on. This does not default in SQL Server. I believe it is the default in Azure SQL Database. So here we can double check and we can see that force last good plan on is happening. And we're going to run that same demo we did over again. So here we'll go ahead and run that our 50 times. It's going to take 12 seconds. Boom, consistent. All right, so we'll go ahead and run the regression. And then this is like the magic demo. This one's fun. So you're going to notice when we first start to run this, it's going to be slow. And after a bit, if I scroll down, you'll notice that scroll bar suddenly starts to move fast. And we finished in 12 seconds for 30. Remember last time it took 18. So what happened? So here we look at our execution plans. We see we have that bad key lookup plan. Query 1, query 2, query 3, query 6, all the way down to query 14. And then suddenly at query 15, we see the plan switched. And we go back to our old good plan. So what happened? If we go look in that same DMV again, we can see that the state transition reason is last good plan forced. So we went from 115, and if we look in query store again now in top resource consuming queries, Microsoft didn't help me with the colors on this one. You see that little check mark, that black check mark on that dark blue circle? That means the plan is forced. And here you can see down here, the plan is forced, and I can unforce that plan. What that means is anytime that query runs, unless something major happens, like an index gets dropped or changed, or there's like a couple of other conditions that can cause it, that query is going to use that execution plan. You'll note it took 15 executions, bad executions, for that to change. That threshold is not configurable. That was something Microsoft just kind of decided to go with. But that's automatic tuning, and I like it. I think that's really cool. It's something that is pretty important. So the one other thing, and I'm not going to do a demo of this, this is introduced in 2019. This is a feature that had kind of a cool code name called Freud. Before 2019, scalar function, user-defined scalar functions almost always really sucked in terms of performance. They did row-by-row execution. The other thing that was terrible about them, if you looked at an execution plan where a scalar function took place, it didn't really show you what operations it actually did. With scalar function inlining, it does. It shows you what it actually does, and it inlines it. It can use parallelism lots and lots better. However, it's got a lot of limitations, so there are a lot of limitations around the feature. So check the docs before you go ahead and turn. This is on by default in compatibility 150. I know there have been some cases where it has caused some weird memory behavior leading to performance problems, and you can turn it off, I think, explicitly. And almost all of these you can turn on and off at the database level independently. So tomorrow, in the same room at 1500, John, my colleague from DCAC, is going to talk about some of the features that are here, but in 2022. So things like parameter sensitive plans. So it's going to build on this talk and what you've learned here today. You can kind of take with you into that talk and see what's new in 2022 and how it's a little bit, even a little bit better than what we talked about today. Does anyone have any questions? Do we have any online questions? Or okay, cool. Well, thank you, everyone. Make sure you go to the sponsors. And my contact info is here. That's my email. Feel free to shoot me an email. My Twitter handle, and then my blog in Redmond. Thank you, everyone, and have a nice afternoon.